And welcome back. This is part 3, chapter 2 communication, A level computer science 9618, and today we will complete our the last part of this chapter 2 communication. And what we are going to cover in this video, let's see here. We will be covering about PSTN, dedicated line cell phone network, bit streaming, which means on demand and real time. What is the difference between these two? Bitrate, what is bitrate? World Wide Web, Internet, what is the difference between these two? URL, DNS, IPv4, IPv6, static, dynamic, public, private, subnetting, CID, NAT, NET, ISP. Okay, let's begin. So here we are. Let's start with bit streaming. So what is bit streaming? Contiguous sequence of data of digital bits sent over the internet. So sending a sequence of digital bits over the internet, right? Necessary to form some form of buffering to ensure smooth playback of the media files like video, like you're watching on YouTube, right? So there's a buffer. The data from the file server is sent to the buffer, and then the buffer will come to the will be sent to the media player in order to play the video, right? So data transmission rate from the file server to the buffer must be greater than the rate at which the data is transmitted from buffer to media player. Okay, so the larger the buffer, the better the control over the bitrate being sent to the media player. So okay, so these are the main 2 points you can see here, the media file, right? So there are 2 types of bit streaming, on demand and real time. So let's focus on demand. On demand bit streaming, digital files stored on a server are converted to a bit streaming format. Okay, digital files stored on a server are converted to a bit streaming format. A link to the encoded video music file is placed on the web server to be downloaded. Okay, so there's a link onto the encoded video music placed on the web server to be downloaded. The user click on the link and the video is downloaded in a contiguous bit stream. Because it is on demand, the stream video is broadcast to the user. The streamed video, music, anything is broadcast to the user as when required. It is possible to pause, rewind, and fast forward the video if required. Okay, to pause, rewind, and fast forward the video, music if required. So this is on demand. What is real time? Real time event is captured by camera and microphone and is sent to a computer. Video signal is converted, encoded to a streaming media file. Video signal is converted to a streaming media file. Encoded file is uploaded from the computer to the dedicated video streaming server. Server send the encoded live video to the user's device. Not possible to pause, rewind, or fast forward. So real time is basically that you're watching television. It's live, giving a live coverage, and definitely you cannot pause or rewind or fast forward it. It's live. It's coming very smoothly. It's coming constantly. The data is coming constantly. Now in on demand bit streaming, it's same thing like watching a video, downloaded video, and watching an online video like on Facebook, on Twitter, on YouTube. And on YouTube you can pause, you can rewind, and you can fast forward it on it, right? On a video or music, anything. So that's the difference between these two. Forward, bitrate. What is bitrate? You can also call it broadband speed. It outlines how fast data can come downloads and can go uploads. Broadband speed tend to be split between download speed and upload speed. Broadband speed is measured in megabits per second, Mbps, and the higher the number of gigabits you are able to download per second, the faster the connection. 5 megabit per second upon 8. You can megabits number of it's in bit form, but you can also convert this in byte form as well. So 5 megabits per second upon 8 is equal to this 0.625 megabyte per second. World Wide Web, a collection of all the web pages, pictures, videos, and other online content that can be accessed through a web browser is known as WWW. HTTPS protocol are written using HTML. Okay. URL specify the location of all web pages. The www use the internet to access information from servers and other computers. What is the internet? Massive network of networks made up of computers and other electronic devices. Uses TCP/IP communication protocols. This is the internet. So that's the difference between these two. World Wide Web is a collection of all the web page, picture, videos, and other online content that can be accessed through a web browser is known as World Wide Web. It contains HTTPS, URL, and it uses the internet to access information from servers and other computers. And the internet itself is known as a massive network made up of computers and electronic devices. Use the communication protocol which is known as TCP/IP. Okay, you will discuss this TCP/IP in A level computer P3 in theory. All right, so yeah, URL, web browser use URL to access websites, more like an address to any website. Okay, use a website. These are represented by a set of 4 numbers such as this. So this is the IP address. This is how the URL looks like. The first part is the protocol, at which protocol you are using for secure data transmission, for having a secure website away from hacking and all that stuff. HTTPS is more powerful, more secure. Then we have the double slash, then website address, the domain name, domain type, country code, www.example.com.pk, okay, domain name, all that. Then you get the path. Path means web pages. There are so many web pages in a website page, like home page, about page, contact page, and all that. File name, item from the web page. Okay. Then we have DNS. DNS is okay. We'll discuss this later. First, we will discuss this later. Let's move on. Then we have hardware used to support the internet. PSTN. What is PSTN? PSTN is the telephone network system. It's a telephone network system. Telephone network system used to connect computers, devices, and LANs between towns and cities. Okay, it is used to connect computer devices and LANs between towns and cities. Telephone line have changed from copper cables to fiber optic cables. It becomes so fast over time. Everything changes. Okay, the telephone lines were in those years. Telephone lines were using copper cables, but now it's using fiber optic cable, which means it becomes so fast. Fiber optic telephone networks are usually identified as fast broadband. Obviously, the telephone line connection is always open. Telephone line connection is always open, whether or not anybody is talking. The link is not terminated. The link is not terminated until the receiver are replaced by both parties. Existing phone lines phone lines use circuit switching. High-speed broadband has allowed VLANs to be developed by using WAPS, wireless access point. Okay. High-speed communication links allow telephone and video calls to be made using a computer and the internet. When using the internet to make a phone call, the user's voice is converted to a digital packages using VoIP, voice over internet protocol. Data is split into packages, packet switching, and sent over the internet through the fastest route. Okay. In PSTN, you are using packet switching, and you can also use circuit switching. What is circuit switching? Two clients share a dedicated line for as long as they need to exchange data. Till communication is active, the channel is busy. Same thing here. Like for example, like Billy and Roger are talking to one another, and they have a very good relationship, and they are talking for hours, and the other customers are waiting, but they can't help it. They need to wait. They have to wait. Okay, they have no choice because these two best friends are talking, and they will keep on talking until they are satisfied with their conversation, right? And then they walk away, and then the next customer will come. Same thing here. So this is circuit switching. Same thing, like for example, if you are going in a car in canteen or in a shop, and you are in queue, you are in a line, because you have to first come first serve. The first customer come, he will purchase some item, then walk away, and then the other customer comes. Same thing here. This is circuit switching. You have to two clients share a dedicated line for as long as they need to exchange data. Till communication is active, the channel is busy. Dedicated lines. Wait. What is packet switching? Switching is used in the internet, right? What are dedicated lines? Dedicated line are a telecommunication path between 2 points that is available. Like two line have a shared dedicated line. Same thing here. A line between 2 points that is available 24 hours a day for use by a designated user. Okay. Cell phone networks. What are cell phone networks? Satellites have the advantage that they will always give complete. So we're talking about satellites. They have the advantage that they will always give complete coverage and don't suffer from signal attenuation to the same extent as underground cables. What are cell phone network, by the way? Being provided by mobile phone companies acting as ISPs. The mobile phone equipped equipped with the appropriate software communicate with a standard cell tower. Okay, so there's a cell tower to access the wireless telephone network, which in turn provides a connection to the internet. So this is then, a radio network distributed over long areas called cell. A radio network distributed over long land area called cells, each served by at least one fixed location transceiver. Okay, this point is very this point is extra. Whenever you've been asked about what is the cell phone network, you will give this answer, that being provided by mobile phone companies acting as ISP. Mobile phone equipped with software communicate with standard cell tower to access the wireless telephone network, which in turn provide a connection to the internet. This would be the best description that what is a cell phone network. Okay, and there's an sometimes we also use satellites instead of cell towers. We sometimes use satellite to have the internet connect to have the connection to the internet, having the wireless telephone networks. Okay, so yeah, this is cell phone network. ISP, companies that provide internet connections and services to individuals and organizations. IP address. What are IP address? So each computer on the internet have a public IP address in order to be identified on the internet. Okay, so there are two types of IP address. There are public IP address and there are private IP address. Public IP address are those which are unique. They are provided by the ISP, your internet service provider. Okay, so every router, the router gives the IP address. If you're connected to the router, then the router which has the IP address, public IP address is identified on the internet. All right, and public IP address is this is public IP address. And what is private IP address? Like, for example, if you have a router and you are connected with 5 computers or devices on mobile phone, laptop, iPad, etc. Okay, so there are different types of devices connected to the same one router. So what will the router will do? The router will try to assign private IP address to each and every devices which is connected, to the router, and so that whenever, for example, if one smartphone is, wanted to watch YouTube, that request will be sent to the router, and the router will do the rest of the job. The router will fetch the data, and then according to that private IP address, will send the data to the smartphone, and in the smartphone you can watch YouTube. And similarly, like for example, a computer is also connected to router, and in a computer you are trying to open your Facebook and you're watching videos, or you're giving a text, or you are replying to your friends. The request is sent to the router, and router will do the rest of the job. The router will fetch the data and then send to that computer according to that IP address. This is private IP address. The private IP address is assigned by the router itself. Okay, so non-unique can be used on other private network, not publicly registered. Obviously it's private. Used internally like a LAN. Assigned by a router, it is free and it is more secure. Okay, in a public IP address, let's, for example, if you want to hide your IP address, if you don't want to, for security reason, you want to hide your IP address, or for more privacy reasons, then you can use a proxy server, like for example VPN. So what does a proxy server do? It tries to give its own IP address and try to hide your IP address. That's proxy, or you can say VPN. We all use VPN to try to access those illegal websites which were banned in our countries. Okay, so that's the difference between public and private IP address. And what is IP address types? Another type, that there are 2 types of IP address. I'm not talking about this. Public and private. Okay, it's a different thing. But IPv4 and IPv6, it's a different thing. So it's talking about the limitations about the IP address, and how many number of IP address it has. IP address, internet based on TCP/IP in protocol, IPv4. So from the beginning, when IP address was formed, it was IPv4. Okay, and it has very limited number of IP addresses. And when when internet become common, and all the people have having smartphones, and they all want to access to the internet, then there was insufficient amount of IP addresses. We were running out of IP address, IPv4. So then what we did, we decided to introduce a new model, into a new version, IPv6, and it has a huge number of IP addresses available to solve the problem, which was insufficient number of IP addresses. So IPv4 is based on 32 bits split into 4 groups of 8 bits, giving 2 of power 32 possible IP addresses, which were not enough for 5 billion users on, or maybe, I'm sorry, 5 or 6 billion, I don't know, approximately, or who knows, on the world, okay, in the world, which it was not enough. And so this is IPv4, and the example is, it's in 4 group of 8 bits, right? It's in denary form. It consists of host ID and a network ID. Host ID is looked at by the receiving network, and net ID is allow for initial transmission to be routed according to the net ID. Okay, we'll see that's what does that mean. Then IPv6, it is developed to overcome some of the problems associated with IPv4, like for example unlimited, limited number of IP addresses which were not sufficient for 5 billion, 6 billion, number of users. Okay, it uses 128-bit addressing split into 8 groups of 16 bits. Example, okay, it consists of hexadecimals and denary. Yeah, right now it's the example I've just shown here is, it's in hexadecimal. Yeah, has built-in authentication. Okay, so there's more security, allows for more efficient routing. Okay, it is in hexadecimal and zeros can be omitted, and it's split in 8 group of 16 bits. So yeah, it has a huge number. We can make a huge number of IP address from this model, IPv6, and that's the difference between, these are the two types of IP address, IPv4 and IPv6. And now we are using IPv6. So congratulations. Okay, let's move on. Static IP address and dynamic IP address. Static means permanent IP address. So here's what is happening. Your ISP, your internet service provider, tries to give you a dynamic public IP address because of shortage of IP address because we are using IPv4. That's what I'm talking about, right? So IPv4 have a low number of IP address. It wasn't enough for all of the users on the world. So here's what the ISP companies do. They try to give those IP address which were just for a temporary period of time until the users become offline. Then that IP address will be taken and will be given to another user to be public, right? So that's how it is. So there's a difference between static and dynamic. Dynamic IP address, it means that it is a permanent IP address assigned to a computer by an ISP. What are the advantages? You can host websites, definitely. Speed and reliability are key. Become very fast when reloading loading the website. Remote access your own PC. You can remote access your own PC. You can control your own PC from anywhere in the world with static IP address. Dynamic IP address, due to having insufficient number of IP addresses, IPv4, the ISP assign IP address dynamically. Not all IP address are always in use. When an IP address is not in use by one person, it can be used by another. It is a temporary IP address. It is assigned to a computing device. That's what I was talking about. Okay, so yeah, this is public, this is private, this is IPv4, this is IPv6, dynamic and static. We are done with the IP address, and now let's move forward on the. Okay, so what is DNS? DNS is domain name system. It gives names for internet's host and is a system for finding IP address of a domain name, which means every IP address is hidden inside a domain name. So what does the DNS do? It makes our job easier by that we won't be able to memorize any kind of IP address because the domain name system will try to find the IP address hidden inside the domain name, right? So we don't need to memorize any kind of IP address. Every IP address is hidden inside the domain name. So it converts a host name, which means a domain name, into an IP address that the computer can understand. Now let's see the type, the classes of IP address. The following blocks are reserved for private IP address. Okay, so this is for private IP address. These are the class A, class B, class C, class A from this to this range. 16 million possible addresses, this to this range. 1 million possible addresses, this to this range. 65,000 possible addresses. Okay, we all know what is happening here. The router is assigning the private IP address. Okay, the private IP address is converted to public IP address using NAT, network interface. NAT is something like, what is NAT? So the private IP address is converted to public IP address by using network address translation, NAT. Okay. Now we are coming to understand about subnet masking. subnetting, CIDR, subnetting. Yeah, let's start from here. So these are the classes of IP addresses. From here to here, it has a number of network ID 8 and number of host ID 24. The type of network, what is the type of network? Very large. So it can be like, this is how the internet can be formed, because it's a very large, the type of network can become very large. Okay, this is class B, so it's medium size. This is class C, this is class D and E. Network ID and host ID. So this is for IPv4. Okay, class A, class B, class C, and whenever we go from class A to class D, you can see here that the network ID is expanding, getting more numbers, while the host ID is getting shorter and shorter. So network ID was less number of network ID, but each network ID has so many huge number of host IDs. That's how it is. Network ID was becoming larger and host ID becoming smaller. Class B, right? Class C, class D, class E. So these are the class for network ID and host ID for IPv4. Okay, what is CIDR, or what is subnetting? Subnetting means divides a LAN into a two or more smaller network. Okay, divides a LAN into two or more smaller network, reduce network traffic, and can also hide the complexity of the overall network. An IP address consists of two parts, the network address and the host address. In order to tell which portion of the IP address is the network or the host, is where the subnet mask comes in. It allows a more efficient use of host ID by applying a structure to it. Subnetting is done by changing the default subnet mask by borrowing some of the bits from the host portion. Subnetting, this is what subnetting is. Okay, let's see what is CIDR. CIDR increase the flexibility of the IPv4 system. A suffix is used such as this. This is a suffix, which means 80 bits will be used for the next ID, and the last 14 digits will be used for the host ID. 18 bits will be used for the net ID, not next. Sorry, this is net ID. Okay. Increase of flexibility regarding which bit represent the net ID and which represent the host ID is the meaning of CIDR. CIDR notation is really just a shorthand for the subnet mask. So this is what the subnet mask means. Okay. Remove the rigid structure and allows the split between the net ID and a host ID to be varied to suit individual need. Allow already existing class A, B, or C address to be used with suffix 8, 16, 24 respectively. So subnetting is done by changing the default subnet mask by borrowing some of the bits from the host portion. Subnet mask, which means we are using CIDR. With the help of CIDR, or you can call it subnet mask, we can do subnetting very easily. Okay. What are the advantages? Manageability, security, improved performance. So this is subnet mask. Okay, here we have a complete table. This is a subnet mask, 24, 25, 26, 27, and 24 means having this number of network ID, and the remaining are host. Using subnet masking, you can make some changes that how many networks it can form and how many number of hosts can be formed. Like if you're using subnet mask 24, then you will have one network, and this network will consist of 254 hosts. Okay, then subnet mask 25, you will get two networks. Okay, you can see the first. Yeah, it will contain two subnet masks. It will, using subnet mask 25, you will get two networks. Okay, and this network will each network will contains 126 hosts. Okay, so it goes on, and the number of network increase and the number of hosts will decreases. Okay, so like for example, if we have an IP address and we have a subnet mask 26, so according to subnet mask 26, which means having 4 network, and each network consists of 62 host ID. So these are the IP address of 4 networks, subnet mask 1, subnet 2, subnet 3, subnet 4. These are the IP address. I mean, these are the IP address of these networks. You know, these are in denary, right? You can see here that this in denary form converted into binary. So you will get, you know, this is in binary. 255, 255, 255, which means all of them are 1, 1, 1, and then we got 2, 128. So you will get this one here, and yeah, you will get this one. So 0 and 1, which means two networks. Then you got this, and you know, and then you got 192. So you got two ones. Then 0, 0, 0, 1, 1, 0, 1, 1. You got four networks. Then you got, you know, and so on. You got 3 ones. You get 8 networks. I mean, this how you are making a network, right? So 1, 1, 1, 0, 0, 1, 0, 0. The combinations of these two digits, you know. So this is how you make a the network ID, right? And each network ID consists of this number of host address, you know, starting from here to here is the number of host address. Okay, then 62. Then when it reaches to 63, okay, then it starts from 64 to 126, I think, then 128 to 190, and you know, wait 64, yeah, 63 from 63. Okay, complete one. You will wait. So if it 63, then 0, 0, 1, 1, 1, 1, 1, and then 1. Okay, so this is how you get number of networks, and then each network will contain the number of, you know, host host IDs. Okay, you are making the number of host IDs from these green zeros, and then the number of network IDs from, you know, these orange, you know, here. Okay, so subnet masking, you know, is a 32-bit address used to distinguish between a network address and a host address in IP address, used by the router to cover up the network address. It stores which bit are used to identify the subnet. Okay, using for example, we have this, and we are using subnet masking. You will have 254 host. Okay, and yeah, that's how it is. This is subnet masking. Always remember that we use subnet masking to make to distinguish between network address and host address in an IP address. So what we are really doing is we are just distinguishing between network IP and host IDs. Okay, yeah, shifting from one number to one, you know, we are doing some shifting, borrowing the number of bits from the host ID and making number of networks. So this is what is subnetting, and I think this is the end of this chapter 3.